Hey there, how are you?
I'm good.
Good.
Hey, Jordan.
Hi.
Y'all ready to work out this review?
Yep.
Yeah.
Okay. All right.
Me and Jordan were working together earlier, and we were wondering if you could help us with
I
14.
can barely hear you, Campbell, and I can hear Jordan really clearly. Can you hear her well, Jordan?
Yeah, that's how her computer is. It's always like that when I FaceTime her.
Oh, okay.
It's
All right, I'm
because
trying really, really hard to listen.
it's because I'm using Bluetooth headphones, and I don't have normal headphones that have a microphone.
Oh, okay. I got you. All right, so you were saying you and Jordan were working it out earlier?
Yeah, we were working together, and we needed some help with 14 through 25.
Okay, great. 14 through 25. Is that what I heard?
Yeah.
Yes.
Okay. All right, let me finish. All right, I've got to do two things. Uh they used my computer um and did an update to it, so it's like nothing's. I thought I had all the little bugs worked out, and apparently not. Sorry. So I'm just gonna skip ahead to those. Is that okay with y'all? And
Yes.
then I'll actually show the answers because I'm going to post these on Google Classroom right after Math Lab. But I wanted everybody to have a chance to kind of work them first. But but I'll let y'all see them because they're at the bottom of this document anyway. But I'm going to skip ahead to 14 right here, right?
Yeah.
Can y'all see it okay?
Yes.
Yeah.
Okay, cool. All right. I'm just going to kind of go through this. I'm going to approach every single one of them the same way, even though our textbook differentiated them between 8.5 and 8.6. The big difference is looking at 14, what is the coefficient on this r squared?
1.
Okay. And looking at 15, what is the coefficient on this x squared?
2.
Okay. The big difference between 8.5 and 8.6 is 8.5 is every single one of them are like 14 with a coefficient, leading coefficient of 1. And in 8.6, every single one of them have a coefficient other than 1. So that's the big difference. But now that you've been introduced to both, I'm just going to go ahead and approach each one kind of the same. And then the other thing I want to bring up is this. Please load. Can y'all see it?
Yeah.
Yeah.
Okay. I want to kind of go through this as I approach each problem. So that's how we're going to be doing the review. So I can pretty much tell you that there's not going to be a common factor, nor is this one going to be the difference of two squares or a perfect square. So that 1 and 2 aren't going to be in this particular one. However, factoring a trinomial in the form ax squared plus bx plus c into binomial factors is kind of where we are on this one. So it's number 3 of that guideline. And what I like to think of is I typically will draw this little line, which tells me I'm multiplying A times C, which A is the coefficient, AX squared plus BX plus C. So A is the coefficient, which Campbell told me was 1 on this, and C is this final term here, which is negative 30. Okay, so 1 times a negative 30 is negative 30, right? Y'all with me so far?
Yes.
No? Okay. Now what I'm going to do is find two factors of negative 30 that multiply to be negative 30, but when I combine them together are going to give me a negative 7. So I'm thinking a lot of times I'm just going to go ahead and approach this like I would if negative 30 were a really big number. So I'm going to write negative 30 over here, and I'm just going to start writing factors. 15 and 2, and then 15 has 5 and 3, right? Yeah. Okay. So what I'm seeing as factors that are going to give me a negative 7 are going to be 5 times 2, which is 10, minus 3. So 10 and 3. And which of those two would need to be bigger based on the fact that this 7 is negative? So the 10 would need to be bigger. So it's going to be negative 10. So I'm going to rewrite this as r squared minus 10r plus 3r minus 30. Okay? Because now my middle term to make up that negative 7 is my negative 10 and my 3. Do you see that?
Yeah.
Okay, so then I'm going to factor by grouping just like I did yesterday. Now, in this first one, what can I take out?
You can take
R.
out R.
Good job. I can take out an r. So when I take out an r of an r squared, what's left?
R.
And then if I take an r out of a negative 10r, what's left?
10.
Negative 10.
All right, what can I take out here?
3.
3.
And that would leave me with r minus 10, right?
Yeah.
Okay, so my factors are going to be, because I have r minus 10, I can factor that out, right? And what's left?
R plus 3.
So now it's factored. Is that making any more sense? I'm going to walk through all of them, but does that make any more sense?
Yes.
Okay. I'm sorry?
We have another method of doing it as well. You know how we could use, for like example from being like 7 through 13, we could use the Punnett square way?
Yes, you like that better?
Well, we figured out you can use it for 14 through 25. You just do it in reverse.
Right. That's the Xbox diamond method, right?
Mm-hmm.
Yeah.
You like that one better?
Yeah.
Yeah, it is easier.
Okay. I'm happy to do it that way. And I always just draw those little lines to kind of indicate that I'm multiplying that 2 and negative 90. That's kind of part of my method of graduating from Xbox Diamond. So what's 2 times negative 90?
180. Negative 180.
Negative 180. So I'm going to put that there. I'm going to put my B term down here. So I'm looking for something that combined, that multiplies together, that gives me negative 180, that when I add them together, I'm going to get a negative 8. Do you know what those are? Or do you want me to factor?
I do not know what those are.
Yeah.
Okay, yes, and you'll get better at this because I can see it and already know that it's going to be 18 and 10, but you will get better at it. You know what I'm saying?
Yeah.
And a lot of times when I factor, I would automatically, if I saw a 10 in it, instead of starting with a 2, I would probably do 18 and 10 like that and then go down to 9 and 2 and stuff like that. But when I would write down that 18 and 10, I would probably see it. Does that make sense?
Yes.
Which one of the two would be bigger, need to be bigger?
It would be negative 18.
The negative 18 would have to be bigger because this term right here is negative. So you like the X box better than grouping?
Yeah.
Yeah.
Okay. No worries. All right. So what I'm going to do is you always put that first term. You always put the first term in this box. And you always put the C term in this box. Always. You all know that, right?
Yes.
Okay. And so then you can put your other two terms in the other boxes. Okay, so what can I factor out of 2x squared and 18x? In this column here.
Yeah, that would be 2x.
Yes. All right, so what can I factor out of the second column?
10.
Yes. Okay, what can I factor out of this first row?
It would be
X.
Looks like I can factor out a 2x, but that doesn't work. That's weird. You know what I mean?
Yeah.
Hmm.
So it's going to give you a 4x, so that's weird. Okay, what can I factor out down here?
9.
And a negative 9.
Yeah.
So that's going to be 2x plus 10. That's a weird one. 2x plus 10. And then x minus 9. So you definitely have to know you couldn't do, you wouldn't. Yee. You would have to know not to factor that out twice. Does that make sense to you all?
Yeah.
Okay. You couldn't, if you factored the 2 out here, you couldn't factor it out in the row too. Now I'm going to, because it's Math Lab, I'm also going to show it written out the other way just so that y'all can see grouping since it's that other method. What you would do here is this. And then you would factor out the 2x there. And then you would factor out a 10 here. So then you would have the 2x plus 10, which is what we got, right?
Yeah.
And then the x minus 9. Now that would be the grouping method. Does that make any more sense to you after doing the Xbox and diamond method? Does the grouping help or not help still?
It helps.
Yeah, it helps.
Not that I care which way. It's just that one had a little caveat to it that made me a little nervous about using it to make sure that you don't, if you factor it out in the column that you can't factor it out a second time in the row, I guess is what I'm trying to say. What'd she say?
I don't know. I can't hear her.
I said yeah.
Okay. Sorry.
Oh, it's okay.
Okay. All right. Number 16. So we're going to multiply 5 and negative 24. which is 120. Negative 120. Yes? Is that what y'all got?
I don't have my calculator with me.
I don't either.
I'm pretty sure that that's what it is. That was me doing it in my head, though, so I better make sure, right? It's 120. Okay, so now we have to find two factors of negative 120 that when we combine them, we're going to get a positive 7. So let's take a look at it. Oops. I would typically start with 12 and 10, but obviously that's not going to get us there. And so then now I'm going to divide this out to 6 and 2 and 20. That won't work either. So now we'll do 5 and 2 down here. Does any of that work? $30 and 4. Nope. That doesn't work. So we'll come out a little further. So some combination of these. Oh, well, there it is. 3 times 5 is 15. And 2 times 2 times 2 is 8. So 15 and 8. And the bigger of the two is going to have to be 15. And the 8 is going to have to be negative because that's going to be positive.
Okay.
Okay?
Yeah.
So if I were doing the X box at the top, the negative 120 would go there. The positive 7 would go there. My positive 15 would go there. And my negative 8 would go there.
Okay.
Does that make sense?
Yep.
I'm going to erase my factoring. So this box is going to be 5a squared. This box is going to be negative 24. And then I put my two terms there. Okay, so what can I factor out of 5a squared and 8a? And what can I factor out of 15a and negative 24?
3.
Now what can I factor out of 5a squared and 15a?
5A.
Good job. And what can I factor out of a negative 8a and a negative 24?
Negative 8.
So then my factors are going to be 5, 8a minus 8 and a plus 3. And what that would look like grouping is 5a squared plus 15a minus 8a minus 24. Just rewriting the whole thing with those factors from my x. And then I would group those. And it would look like this. So that's the grouping method and the Xbox diamond method. And it gives y'all a little bit of time to write it all down. And it gives you an opportunity to see more of that grouping since that'll be on the test too, you know?
Yep.
The key thing, probably the most, tedious part of this is finding the actual factors. You know what I'm saying?
Yeah.
And that's just a matter of, learning to factor kind of quickly. And I think And I think, when I talk to y'all in class about this, I love the birthday cake method because for me, it's easier to look at all of the factors on the outside of that birthday cake thing as opposed to the factor tree and trying to figure out where all those end. Number 17. I'm going to multiply my 3 or my 3 and my -1 because that's my A and my C, right? And 3 times -1 is -3. And then I'm going to put my B term down here at the bottom. And what two things multiply together to give me -3 when I combine them give me a +2?
3 and -1.
Good job. So then in my box, I write my first term and I write my final term. And then I write my factors. So what can I factor out of a 3p squared and a -1p? P. And then 3p minus 1. Only thing I can factor out is a 1. And then 3p squared and 3p. What can I factor out of it?
3p, yeah.
And then out of the -1p and the -1. So then what that would look like grouping, because you just write your terms. Whoops, forgot to write my P there. So we get the same thing. Just kind of showing it both ways. The grouping way. Had y'all done that one? Was that one easier because the numbers were a little smaller?
Yeah.
Okay, cool. That was 17, right?
Yes.
Yes.
Okay. Take a look at number 18. And this is kind of when we talking about our guidelines. Whenever I look, the first thing I do when I look at a problem is I want to look to see if that first term is a perfect square. That's this number 2 thing. Look for a difference of 2 squares or a perfect square trinomial. So, and the first thing that you do on that is you look at that first term. Is 25k squared a perfect square?
Yes.
It sure is. Is 1 a perfect square?
Yes.
Yeah.
It sure is. So, what I want to do then, what is the square root of 25?
5.
And the square root of 1?
1.
Okay, so what's 5 times 1?
1. 5.
Okay, and what is 5 times 2?
10.
So this is going to be a perfect square trinomial. And what that means is I'm going to take the square root of the first one, which is 5k, like y'all told me, and the square root of that final term, which is what? 1. So it's going to look like that.
Okay.
Okay? So that's one of the things that you want to do is look for and see if it's a perfect square. Okay, on number 19, is 9v squared a perfect square?
Yes.
Okay, what is the square root of 9v squared?
3v.
Uh-huh. Is 1 a perfect square?
Yes.
Okay, and the square root of it is 1. And what's 3 times 1?
3
And 3 times 2?
is 6.
So I know this is a perfect square trinomial. So I would just write the square roots of the first term and the last term and then square it.
Okay.
The big difference, though, on these is if this middle term right here on either 18 or 19, had they been negative, this middle term here would have been negative. So that would have been 5K minus 1 or 3V minus 1 if that middle term had been negative. Does that make sense to you all?
Yes.
Okay. Good job. Because a negative term doubled obviously is negative when you combine those. All right. Now, number 21, 20 and 21, these are on this. These are the difference of two squares. And let me show you how to recognize that. The difference of two squares is when there's only two terms, which 20 and 21 both fit that. And there's a minus sign in the middle because difference means subtraction, right? So the first thing that you're going to want to check is, are there two terms? And both 20 and 21 have two terms. Then you want to check if the first and then you want to check if there's a subtraction symbol in the middle, and there is. And then the third thing that you want to check is, are the terms perfect squares? So for number 20, is n squared a perfect square?
Yes.
Yes. And what is the square root of n squared?
N.
And is 9 a perfect square?
Yes.
Okay, what's the square root of 9?
3.
Okay, so then the pattern is you're going to have an n plus 3 and an n minus 3. When it's a difference of two squares, you just put the square root of each of them in parentheses and separate one by a plus sign and one by a negative sign. It's a pattern.
Natty Grace just
Oh, yeah, I remember.
Okay, Natty Grace just joined us.
yeah,
Hey, Natty Grace.
she said sorry she's late. She had to get a tooth pulled.
Oh, no worries. And if she has additional questions over some that we've already covered, I can always go back over them too. So, Natty Grace, we're going through the last few on the back page. Ooh, I just saw that you got a tooth pulled. Yuck. Bless your heart. I'm sorry. Okay. Bless her heart. Okay. Number 21. The difference of two squares. Well, we have two terms here. So we want to confirm that the first term is 4n squared, a perfect square.
Yes,
Okay. What is the square root of 4n squared?
2n.
Is 25 a perfect square?
Yes.
What's the square root of 25?
5.
So my two terms are going to be the square roots of each of those terms, separated, one by a plus and the other by a minus. That's the difference of two squares. That's how you factor that. Does that make sense?
Yes.
Do y'all see that pattern pretty clearly? And can you tell the difference between 18, 19, 20, and 21?
Yes.
Those four problems refer to step 2 in the guidelines for factoring polynomials that I had y'all write down yesterday. That's step number 2. That's what you're looking for in those types of problems. Okay?
Okay.
All right. Now, more fun with factoring. The last one is factoring by grouping, the last few. And typically on these, what I like to do is, first of all, try to put them, in some type of order where they're easy to factor. And this first one, it looks like it's in a pretty good pretty good order to go ahead and start. So typically and this is going to be also, I'm sorry, let me back up a minute. I apologize, guys. This is step number 4, factor a polynomial with 4 terms by grouping. So obviously we're looking at this, we got 4 terms, so we want to put them into groups. So we're going to group this one, the first 2, and then we're going to group this second 2.
Ah, sorry.
Oh, are you okay? Or did the math problem scare you?
I don't think it was a math problem. I think something happened. She's on mute now.
Oh, okay. I hope she's okay. Should I go ahead?
Yeah, she'll be fine.
Okay. Okay, so what can I factor out of a 4r cubed and a 35r squared?
You can factor r squared something 5r squared.
Good job, 5r squared. So if I took a 5r squared out of 40r cubed, what would I have left?
8r plus 7.
Perfect. Okay, what could I factor out of a negative 64r and a negative 56?
Negative
8.
Negative 8. Good job.
Jordan, you're back.
Yeah, sorry. My mom came into my room and was behind me, and she scared me to death.
Bless your heart. Okay, so if I took a negative 8 out of a negative 64, what would I have left?
plus 7.
Yep. So then what do I have what do they have in common?
8r plus 7.
So that's going to be my first factor because I'm factoring that out. And what is left?
5r squared minus 8.
So now that's number 22 factored. Okay. So for 23, factor, once again, I have 4 terms, so I'm going to select factoring by grouping. What can I factor out of 40r cubed and negative 48r squared?
8r to the second.
8r to the second. Okay. What would I have left once I take 8r squared out of 40r cubed?
5r minus 6.
Good job. What can I take out of a negative 15r and a positive 18?
Negative 3.
And that's going to leave me 5r minus 6. And what do they have in common?
5r minus 6.
And then what's left?
8r to the second minus 3.
Good job. Good job. Okay, how are y'all seeing this pretty well?
Mm-hmm.
Yes.
Jordan,
Yeah.
how are you doing, baby?
Good.
After your mom scared you.
I'm good.
Okay. Are you seeing all this okay?
Yes.
Okay, cool. And Campbell, you are too?
Yeah.
Okay, cool. All right, this last one. If this were me, I would probably rewrite this problem. You wouldn't have to, but if it were me, I would rewrite this problem with the 21n closer to the 7n cubed and the 6n squared closer to the 18. Do you all understand why I might do that?
Because they have more things you can take out of them.
Yes. But you would not have to. You're still going to get the same answer, but there would be more things in common. Exactly. So I would just restructure this problem for it to look like this. Fortunately, these are all plus signs. So, but if they weren't, every sign has, a number, and every number has a sign. So you would want to make sure you carried those along. And then we're going to factor by grouping. In this first set, what can I take out?
7 in.
7 into the no, just 7 in.
Yeah.
So what do I have left here?
Into the second
Yeah.
plus 3.
Okay. And what can I factor out of this second set?
6.
And I would have n squared plus 3 left. So what do they have in common?
N squared
Squared to
3.
plus third 3, whatever.
And what's left?
7 in plus 6.
So there's my answer. Okay, on this last one, I would also rewrite this one. How would you all rewrite it?
56.
Minus 56b.
You would move it over here like this.
And that's 5.
Good job.
5 squared. 35.
So like that?
Yes.
Okay. All right, so then we're going to group this first set together and then group the second set together. What could I take out of this first set?
8b to the 8b. Yeah.
Okay, what would be left?
B squared minus 7.
And what could I take out of this second one?
5, just 5.
And I would have b squared minus 7
Yep.
left. So they have in common the b squared minus 7. Oops, sorry about that. Well, goodness. And then 8b plus 5 is what is left. So that's your answer. And then if you want to check the rest of your worksheet, here are the answers. And I will post these also.
I gotta go. We'll see you guys in class tomorrow.
Okay.
Okay.
Have a great day.
I
Thanks
gotta
for
go
coming to
too.
Math Lab. You got to go too, Jordan?
Yeah. Bye.
Bye-bye.
I gotta go too.
Okay. All right. Take care, Natty Grace. Take care of yourself. Don't drink from a straw.
Too late.
I don't want you to. What is that you get? I forgot. Or maybe you don't get it with where depends. I guess it depends upon where your tooth was pulled.
It was from the very back of my mouth.
I thought there was something called, I don't know, something socket. What is that called? Now I can't think of it.
I don't know.
Okay. They didn't tell you not to?
No, it's just really hard to drink from a straw.
Oh, okay. Well, bless your heart. Please take good care of it. Take good care of yourself.
Bye.
Bye. Hey, Matthew. How are you? Do you have a question about a particular problem, or are you just checking your answers?
I'm just looking at my answers.
Oh, okay. I'm getting ready to post them too in all of the Google Classrooms,
Okay.
just so you'll have a copy. Oh, you doing good on it so far?
I've got them all right so far.
Oh, good. Yeah, I just got it posted in your class.
Okay. All right. Bye, Miss Sparks.
Bye.
Good
Have a
rest of your
great day. Hey, do you have any questions about geometry that I could help you with?
No, I don't. I just took the exam yesterday for geometry and I got an 81 on it.
Oh, good. For the
So,
final exam?
yeah, it was just the exam at the end of the chapter.
Okay, which chapter are you on? One, two?
I'm on 3.
Oh, on three. Okay, good job. I think I remember. I was trying to remember. I just remember that the first semester was hardest for Mackenzie, and then the second one was a lot better because it was more formula based.
Okay. Cuz I did really bad on that lesson, but then I we got a tutor and now I did better on that. Or I did better on the exam.
Oh, okay, good. Who'd you get for a tutor?
It was I think he's a professor at Lassiter and he
Oh,
lives in my neighborhood. So,
oh, awesome. That's great. Oh, I'm so glad that you got help. That's awesome.
cuz we tried Mr. Sickley, but since my geometry was so different from the one they teach at Cornerstone, it was kind of hard for him to help.
Yeah, and because I think at the very end you end up in the same place,
Yep.
but I think their structure is different and you can't use because I remember when I was trying to help Mackenzie getting used to which postulates and theorems she'd been introduced to because technically you can't use a postulate and theorem until they've introduced it. So if you're trying to
Mhm.
prove something, I don't know. It's just really kind of hard. But I'm so glad he was able to help you. That's
Me
awesome.
too.
All right, and I hope it keeps going up from there.
Okay.
I really do feel like the program gets a little easier as you move through it. So have a
All right.
great day, sweetie.
All right, you too.
Bye bye.
Bye.